So this time we're going to talk about unit vector. What is this unit vector? When you say unit vector, this is a dimensionless vector. It means it has no width, it has no height, it has no length, but it has a magnitude of exactly equal to 1. Unit vectors are used to specify a direction. So what's the use of unit vector? This is to point or to describe the direction of the direction in space, and it has no physical significance. It's just to point the direction in space. Okay. Unit vectors provide a convenient notation for many expressions involving components of vectors. So there is unit vector along each component of a single vector. There is a unit vector along x-axis, along y-axis. There's also a unit vector along k-axis, z-axis. So how will we represent unit vector? Unit vector is represented by a letter with caret above it, or what we call hat. Sometimes it's called hat. So suppose we have vector A. What is the unit vector of A? Then we read this as A hat. It means a unit vector of A, or unit vector A. So it's better to read this as A hat than unit vector A, because when you say A hat, it means a unit vector of A, and then it's too long to read unit vector A. So it's better to read A hat than unit vector A. So again, A hat is a unit vector of vector A. Okay. There is unit vector along x-axis, what we call I hat. Okay. A unit vector along x-axis is I hat. The magnitude of that vector, the unit vector, is again equal to 1. And j hat, it points in the direction of y-axis. And then k hat, it points in the direction of z direction. Right? So I'll consider here a three-dimensional vector. So any vector can be expressed in terms of its components as I'm sorry for this. So just write it. So any vector can be expressed in terms of components as, okay, suppose we have vector A. That is vector A, and then we will express that in terms of components. Then we will have A of x as the x component of that vector A times the unit vector along x-axis, that's I hat, plus the y component of vector A times the unit vector along y-axis, that is j hat. Okay, j hat is the unit vector along y-axis, plus, okay, so let's consider the three-dimensional vector here. So we have az as the z component of vector A times k hat as the unit vector along z-axis. So I hat is the unit vector along x-axis, j hat is the unit vector along y-axis, and k hat is the unit vector along z-axis. I hat is the unit vector along x-axis, j hat is the unit vector along y-axis, and k hat is the unit vector along z-axis. Now, vectors can be expressed according to their magnitude and direction, and also vectors can also be expressed in terms of their components with their unit vectors. So if you can still remember that vectors can be expressed in terms of magnitude and direction, then we have vector A equals the magnitude A times theta as the direction. So this is the magnitude, and then this theta is the direction from positive x-axis, then in counterclockwise direction. counter clockwise direction. Okay, so again, vector A can be expressed in terms of magnitude for two-dimensional. Theta is the angle between the vector and the positive x-axis in counterclockwise direction. And also, if we're going to consider components and unit vector, then vector A can be expressed in terms of components. Then we have A of x times I hat as the unit vector along x component plus ay times j hat as the unit vector along y component. So what if a vector is expressed in magnitude and direction? So how will we express that in terms of components and unit vector? Right. So suppose we have vector A equals say 5 meters, comma 150 degrees. Right. So if it is 150 degrees from positive, okay, this is the x-axis, y-axis, and this is the x-axis, then unit vector is located at the second quadrant. That's vector A, right? And then that is 150 degrees from positive x-axis. So if it is located at the second quadrant, so it means it is expected that the x component is negative, right? And the y component, since it's above the x-axis, is positive, right? So 150 degrees. So let us express this vector, since this vector is expressed in magnitude and direction from positive x-axis in counterclockwise direction. We will express this vector in terms of component, x and y components, and since this is a two-dimensional vector. So what is the x component? That is the the magnitude of vector A, cosine of the direction of the 150 degrees, and that is equal to 5 meters cosine of 150 degrees. So the x component of vector A is negative 4.33 meters. How about the y component of this vector A? A of y is the magnitude sine theta. And what is the magnitude? 5 meters sine of 150 degrees. Then that is 5 sine. Right. So that is the y component of vector A. So that's 2.5 meters. So we can now express this vector A, in terms of its components. So vector A, okay, equals the x component, right, and then I hat plus ay, or the y component of vector A, times j hat, a unit vector along y-axis. So vector A equals what is a of x, that's negative 4.33 I hat, right, plus the y component, which is 2.5. So you have 2.5 okay, so 2.5 j hat. So this is how you express vector A. Since vector A is expressed in magnitude and direction, we can express that in terms of components, x and y components. Okay, so let us have another example of vector expressed in magnitude and direction, and then we'll express that in terms of components. So we have vector B equals 10 Newton, 210 degrees. So if we have a x and y coordinate system, 210 is located at the third quadrant, since this is 180 degrees and this is 90 degrees. So in third quadrant, it is expected that the y component is negative, and then also at the x component, this one, the x component is also negative. So let us see if it is negative, or the x and y components are negative. So again, we'll express this in terms of components. So we'll have to determine first the the x component of vector b. So they have b of x equals b cosine of 200 theta. So what is b? The magnitude of vector b, that's 10 newtons. So you have 10 cosine of 210 degrees. So let's calculate. That's approximately negative 8.66 Newton. That's the x component. How about the y component? The y component, by, right? That is the magnitude, sine of its direction, theta. What's the magnitude? 10 Newton. Then that is 10 sine of 210 degrees. That is so by equals negative 5 Newton. So see, both x component and y component are negative, right? So we can now express this vector b in terms of its components. Then vector b equals b of x I hat plus by j hat, or vector b equals, what is b of x? That's negative 8.66 I hat. We're going to consider the unit. Then we have negative 8.66 Newton I hat plus the y component, which is negative 5 Newton, and then negative 5. So that's plus negative, then it becomes minus 5 Newton j hat, right? So we express vector b, that is in terms of magnitude and direction, in terms of its components, x and y components. So let us have the last example. This vector is expressed in terms of magnitude and direction from positive x-axis, counterclockwise direction. So we will express this in terms of its components. So again, the first thing to do is to find the x component of this vector c, and also the y component. So let's start with the x component. That's c. Then we have c of x equals the magnitude c cosine of theta, right? Then c has a magnitude, vector c has a magnitude of 6 meters. So then this is 6 meters cosine of 60 degrees, right? So let's use calculator. 6 cosine 60, that's 3. The x component is 3 meters. How about the y component? The y component is the magnitude c sine of theta. Then magnitude of vector c is 6 meters. So this is 6 meters sine of 60 degrees. So what is 6 sine 60? That's approximately 5.20. So we have 5.20 meters. That's the y component. So we can now express this vector that is expressed in magnitude and direction into its components. Then vector c is equal to cx I hat plus cy j hat. Our vector c is, what is cx? The x component, that's 3 meters. So you have 3 meters I hat plus cy 5.20 meters, and that is 5.20 meters j hat. So we express a vector c that is expressed in magnitude and direction into its components with unit vectors. So this time, a vector that is expressed in its components will be expressed in terms of magnitude and direction. So this is the given vector. Vector A equals the x component is 3 I hat minus 4. That's negative 4 is the y component of vector A. So you have j hat as the unit vector. So we'll express this in terms of magnitude and direction. Alright. So since the x component is positive and the y component is negative, so where do you think the vector is located? At what quadrant? This is two-dimensional vector. So at what quadrant of xy coordinate system the vector A is located? X is positive and y is negative, so it's expected that the vector is located at the 4th quadrant. Alright, 4th quadrant. So this is the y component, negative y, and this is the negative, the x component, which is x, positive x. So this is the x component. So let us express this vector in terms of magnitude and direction. Right. So we know the magnitude is square root of the x component squared plus the square of the y component. Right. So a of x is 3, a of y is negative 4. So we have the square root of negative a of x is 3, then that is 3 squared, plus the y component is negative 4, so this is negative 4 squared. So that is the square root of, this is 9, this is 16, 9 plus 16 is 25, then we have square root of 25. What is the square root of 25? That is 5 units. So the magnitude of vector A is 5 units. Right. How about the direction? Theta is the inverse tangent of AY over AX. So it's inverse tangent of what's AY, negative 4 over 3, right? So inverse tangent so theta is negative 53.13 degrees. Why is it negative 53.13 degrees? Now again, if this is the x and y axis, the xy coordinate system, the vector A is located at the 4th quadrant. When you say 53, since the x-axis, the x component is positive and the y component is negative, then the direction here, this negative 53.13 is measured from positive x-axis in clockwise direction. So this is negative 53.13. So if we're going to measure the angle from positive x-axis in counterclockwise direction, so what are we going to do? We will add negative 53.15 by 360 degrees. So theta is 360 degrees plus negative So theta is 360 degrees plus negative 53.13 degrees. And what is, then we have 306.87 degrees. So this is the direction of the vector A, right? The fourth quadrant, I mean. Okay, if it is measured in counterclockwise direction from positive x-axis, then we have 306.87 degrees. Alright, and 306.87 degrees is between 270 and 360 degrees. This is 360 degrees. Right? Now, where is this negative 53.13? Again, from positive x-axis in clockwise direction. So this is negative 53.13 degrees. So we can now express vector A in terms of magnitude and direction. So vector A in terms of magnitude and direction is magnitude 5 units. You can have any unit. And direction 306.87 degrees. Right. So we'll have another example of vector that is expressed in terms of components, and then we'll express this in terms of magnitude and direction. So given this vector, negative 10 I hat plus 5k hat, the x component of that vector is negative 10 units, and the y component of that vector is 5 units. So we'll obtain the the magnitude of vector B. So B is the square root. B is the magnitude of vector B. B is bx squared plus the square of the y component. Then vector B is the square root of negative 10 squared plus 5 squared. Then square root of B. B, the magnitude of B, let's use calculator. 10 squared. So B is 5 square root of 5. Okay, so you have B equals 5 square root of 5 units. Alright, how about the direction? Theta is the inverse tangent of the y component over x component. So theta is, what is a of y? No, we have vector b, then this is by over bx. What's by? 5 over negative 10, then that is it's approximately negative 26.57 degrees. What is this negative 26.57 degrees? Now, this is the x and y component, x and y axis, x and y plane. This vector B has a negative x component and it has a positive y component. So it means that vector is located where? At the second quadrant. At the second quadrant, vector B is located. So it is expected that the direction from positive x-axis must be greater than 90 degrees. It's 90 degrees, but less than 180 degrees. But how come it's negative 26.57? That negative 26.57 is from negative x-axis in clockwise direction. That's negative 26.57 degrees. So how we're going to have a angle measured from positive x-axis to vector B in counterclockwise direction. Then we're going to add 180. So theta is 180 plus the negative 26.57 degrees, because the angle must be less than 180 but greater than 90 degrees. So we have 180 and theta is 153.43 degrees from positive x-axis. So this is 153.43 degrees. Alright, so we can now express vector A in terms of magnitude and direction. Oh, come on, this is vector B. So vector B is the magnitude 5 square root of 5. You have 5 square root of 5 times the direction 100. Vector B is 5 square root of 5, okay? And then comma, the direction 153.43 degrees. So a vector in terms of components is expressed in terms of magnitude and direction. So a unit vector has a magnitude equal to 1, and it is expressed by a letter with caret, a symbol caret above it, and we read this as a hat or unit vector A, and it's better to read this as a hat, and it is understood that it is the unit vector of vector A, and this is equal to the vector itself over its magnitude. Suppose we have a given vector A equals 3i hat minus 4j hat plus 3k hat. The x component of that vector is 3, the y component of that vector is negative 4, and the z component of that vector is 3. Okay, so let us obtain the unit vector of vector A. Okay, so first thing to do is to look for the magnitude of vector A. So since this is a three-dimensional vector, then we have vector A equals ax squared plus ay squared plus az squared. So z, we consider now z as the third component. So we have square root of what is ax, that's 3. We have 3 squared plus y, the y component, then that is negative 4 squared. Az, the z component is 3, then this is plus 3 squared. Alright, so vector A, the magnitude of vector A or A is, this is 9 plus 16, 25 plus 9, that's 34. So you have square root of 34. So the unit vector A or A hat, unit vector A, is the vector itself. So you have the vector itself is 3 I hat plus minus 4 j hat plus 3 k hat over all over. Okay, so each component is divided by square root of 34. So that is the magnitude of vector A, square root of 34. Alright, so let us check if the magnitude of this unit vector, vector A, is equal to 1. So the magnitude of unit vector A, magnitude of unit vector A must be 3 over square root of 34 squared, right, plus negative 4 over square root of 34 squared, then plus for z, that is 3 over square root of 34 quantity squared, right? So okay, so 3, that's 9, they have square root of 9 over 34 plus 16 over square of the square root of 34 is still 34 plus 3 squared is 9 over the square root of 34 is just 34. Then 9 plus 16 plus 9 is 34 over 34. What is the square root of 34 over 34? That's the square root of 1. And what is the square root of 1? So the square root of 1 is 1. So we have the magnitude of vector A equals 1. Okay? It's always equal to 1. This is the unit vector of vector A. Another example, a vector that is expressed in terms of components with unit vectors. So you have vector A equals negative 7i hat plus 2j hat minus 3k hat. So this vector A has x component with negative 7 units, the y component is 2 units, and then the z component is 3 units. So what is the unit vector of vector A? So again, unit vector A is the vector itself over its magnitude. So what's the magnitude? We don't know. So we will look for the magnitude of vector A. So vector A equals, not vector A, but the magnitude of A. Magnitude of vector A, which is A, and that is the square root of negative 7 squared plus 2 squared plus negative 3 squared. Okay, and that is the square root of 49 plus 4 plus 9, and then it's 49 plus 4 plus 9. The magnitude of vector A is the square root of 62, right? 49 plus 4 is 53 plus 9 is 62. Alright, so the magnitude of vector A is the square root of 62. So the unit vector of vector A, unit vector is the vector itself over the magnitude of that vector. Then that is negative 7i hat plus 2j hat minus 3k hat over the magnitude, which is the square root of 62. Right. So let us double check if this is really the unit vector of vector A by looking at the magnitude of unit vector. So again, remember this, that the magnitude of the unit vector is always equal to 1. So let us try this one. It means the absolute value or the magnitude of unit vector A is the square root of negative 7 squared plus 2 squared, right, plus negative 3 squared all over the square root of 62. So we will include this squared. Okay, so that is square root of 47 squared, 49 plus 4 plus 9, that's 62, over the square root of the square of 62 is still 62. Then unit vector A has magnitude equal to 1. So that's how you double check. Okay, if the magnitude of that unit vector is not equal to 1, then that is not a unit vector.